with all of our elements laid out, the next stage is to start adding scripts which will provide the interactivity for all of these things. And a good place to start will be the player. So here in the main scene, we're going to add our scripts here. And so I'll select the player and press this button here, which looks like a little scroll of parchment with a plus button. All of these settings are fine for what we need, just making sure that it is indeed a kinematic body. Otherwise, this won't work. Click Create, and here we are with a basic script, which we can now edit. The first thing we're going to do is give our character some movement, and to do that, we need to set up several variables. Variables are bits of information that the objects can use to do different things, in this case move in a direction. So one of our variables will be speed, and we would write it like this, VAR, and you can see that comes up in red letters. Speed. Speed is a name that I've given it, and so it comes up in white letters. If you get colourful letters when you type any words, it's probably because they are what are called reserved words. So things like this, ready, pass, we couldn't use them as our names for variables and other things. We have to come up with our own names. So keep them short and unique, and make sure they don't have any spaces in. That's or punctuation really. That's the main rule. Quite often you will see people use what's called camel notation. That's the way I tend to do it. So for example, you might see something like that, speed up, where every new word is capitalized at the start. Other people might put an underscore and then another word. Both of these are fine, but we want to avoid things like this, because these, as you can see, are coming up in blue, which means that they're not appropriate characters to use for our unique identifiers, because they're reserved by Godot for other things. So the variables we're going to set are speed, and we're going to put speed equals, and I'm going to put 900. You can change this to whatever seems most appropriate for you, but we'll leave it like this as it is and see how it looks, and then you can change it later. We're going to create some more variables. This one is the direction, and in this case we simply use this instruction, vector 3 and then brackets, and you will get kind of help with the typing. So you'll see as I type this next one, which is velocity, which is another vector 3, as soon as I start writing vector 3 it sort of pops up in a list, so you can choose it from there if you want to. The last one we're going to make for now is called gravity. And the standard gravity that is used is 9.8. It's important to look at how the words are spelt, whether they've got capital letters in or not. All of these things really, really matter. So if something is not going correctly with your game, then first port of call is to look at your code and check that what you've written is actually what you should have written, or whether you've made some mistakes. With our variables in place, we're now going to move down here to this bit that's greyed out. You can see it's greyed out, and the reason it's greyed out is because a little hash has been put in front of the line. So I'm just going to delete that hash, and you'll see that it becomes colourful. This area is a function or a set of code that is going to be called or executed every frame, and so it's really good for updating things like which direction is the player moving in, or have they jumped, things like that. Because we're going to perform some physics in this function, at the start here I'm just going to change the name of it and add underscore physics to the beginning, so it should say underscore physics process. And I'm also going to delete this pass. Pass simply means it's kind of saying skip, so we actually have to replace that, otherwise it might not do any of our code. So first thing, delete that. The first thing we're going to write is direction equals vector 3, and then in the brackets this time 0, 0, 0, and these reference the x, y and z axes in our 3D world. So at the moment we have a direction of nothing in all axes. So that's our starting point for this function. Underneath that, by pressing enter, we're going to look for when a key has been pressed on the keyboard. I'm going to use the arrow keys. So we're going to say if one of these keys has been pressed, then do something. And we write that like this. If input is action pressed. And in the brackets here, we're going to write in which input we want. We can select it from a list here. You can actually move down these lists by pressing the down arrow on the keyboard. And this is the one I want, UI left. I could either type it directly into the brackets in making sure I put these quotation marks on it, or I can just tap that there and it places it in there for me. Because we're asking this question, if the button has been pressed, underneath we need to say what happens if it has been pressed. And I want you to look carefully how we write it. At the end of this if statement or question, we put a colon. Then we make a new line. It has automatically indented the new line where we're going to write direction dot x minus equals 1. So what we've written here is if this left button has been pressed, move our player on the x-axis -1 every frame. So because this function is being called every frame, this is happening every frame. So provided our left key is down, it will keep moving us left. Back to these indentations. Indentations show that a section of code is dependent on or contained within these larger statements. So we have a function, and you can see that everything we've written so far is within that function. It's all been indented at least once within that function. If I were to write something here, this is nonsense. It's not included in this function. The information up here is not included in this function. It sits outside of it. Again, with this if statement, the if statement happens within the function, and then as a sub-level, another indentation in, this only happens within this if statement. So something else to look for in your code is that the indentations are correct. You don't want too many, you don't want too few. So if there's problems with your game, then indentation as well as spelling and punctuation is really important. The next couple of lines of code are going to be very similar to this because we're looking at the right key. Obviously in a 3D game you're going to have more keys, but in this tutorial we're just going left and right like in a platform game, and so that's all we're going to do. So I'll make a new line and I'm just going to press backspace because I want to create a new if statement that is not reliant on here. Just as an example, if I were to write my if statement here and make it check for the right key, in fact what would happen is it would only check for the right key if the left key was already pressed down because of the indentation here. If I do this, then this if statement is not reliant on this one and the function will check for them separately. So I'll choose input is action pressed, and we want UI right colon and a new line, and this time direction is going to go the other way, direction x plus equals 1. So we're going to add 1 to its current direction every time along the x-axis. This in itself doesn't actually move our character. This is sort of doing the maths behind it. And in fact, we need to take the information from here a little further in order to make it work. So on a new line, still within this function, but outside of these if statements, we're going to work with this direction value that we've created or been altering and write direction equals direction full stop normalized. And this will sort of round up the figure that we get from our direction calculations here. Then we will give our direction some speed, because it's all well and good facing in a direction, but if you've got no speed, you're not going anywhere. And this is where our speed variable from the top, from up here, comes in. Direction multiplied by, and you'll notice that this is the asterisk you get if you hold shift and press your 8 key, number 8, direction multiplied by speed, and then multiplied by delta, which is the amount of frames. And then finally, I'm just going to skip a line here just to space out some of my code a little, and we're going to write direction equals move underscore and slide. So we've got underscores beneath them. Again, it appears in the list here. Direction, comma, vector 3, and then 0, 1, 0 to apply it. To see whether our code is working, we need to test the game. And to do that, we can press this play button up here. It asks us to confirm a main scene, so we can click select, and from the options here we'll choose our main scene and press open. And as you can see, we can't see anything, and this is because despite being able to see everything nicely in the viewport here, we have no camera to help us render the view. So our next job, in order to test the game, we're going to need to add a camera. With the main object selected, we're going to choose the plus button, and in the box here we can type in camera, and here it is. We can just move that into a new position. This little icon's a bit misleading because it doesn't really show the direction the camera's facing, but if you're getting quite close you can see a little sort of mesh here that shows you the actual direction of the camera. Just going to pull that back. If you want to see what the camera's seeing, you can press preview. So we'll come a little further back and perhaps up a bit. You can position your camera wherever is appropriate. There we go, I can see everything now. So I shall go back to the script just by clicking here and press Command and B. And as you can see, when I press the right and left keys, it moves in that direction. It doesn't really do much else because we haven't told it to. And in fact, whilst it goes uphill, there's no gravity to allow it to fall. So it just floats about the place. But that's our starting point for now anyway. So in order to make the physics a bit more realistic, we're going to make a few changes and add some code in. We created two variables earlier called velocity and gravity, and that's what we're going to use now. So just here in this gap between these directions, I'm going to add some information for the velocity. And the first one I'm going to add is the one we will be using gravity in. Velocity Y. If you're used to Blender, you'll probably be aware that that has the Z axis as up and down, whereas Godot uses the Y axis for up and down. So we've just got to try and remember that. And we're going to say in each frame we will make the velocity equal or add gravity multiplied by delta. So it increases it. And velocity X, which is going to equal direction X, because we know that's okay. Ooh, I've added some stuff there which I didn't mean to. Okay, X, new line, velocity, yeah, Z equals direction Z. So now we've given velocity some values, and what we're going to do now is just change, instead of direction here, we're going to update this to say velocity. So instead of using the direction information to control our character, we're using this velocity information. So having updated our code, we can test our game again and look how the velocity has affected the physics in the game. And off he goes. So at the moment, the player is able to float up off the screen. So we need to control that. Just underneath velocity here, we're going to add some code to look at velocity and make some decisions about how it works. So we can write if velocity Y is greater than 0, then gravity is going to be stronger, and it's going to equal minus 20. However, if I just make sure I undo that indent there, we can write the word else. So what we're saying, if velocity is greater than 0, then do this, Otherwise, else, gravity is going to equal minus 80. And we should be able to see this affect it in a much more useful way. Our player is stuck to the ground, that's a good start. It moves along the platform, and it also falls when there's no platform beneath it. So we've got some gravity going in the game as well now. So the next job is to get the character to jump so that it doesn't just fall off the edge, and we've got some control over those gaps. So to help us with jumping, we can make use of a method called isOnFloor, which checks to see whether our player is touching the floor of the level. So I'm going to make a new line in my code, just separate it a little bit. The gaps in the lines don't matter so much, it's really just personal preference, but of course all the other things do, indentation and punctuation and so on. And the code we're going to use is as follows. If is on floor and then a colon, so brackets and then a colon, and we need to indent this because it's part of our if statement. So we're saying if this kinetic body, this player, is on the floor, then velocity in the y-axis is going to equal minus 5. And the reason that I've put this in is because sometimes the collision mesh for the kinetic body doesn't detect that it's on the floor all the time. So having a little bit of velocity sort of just pushes it down into the ground and really makes that connection so that we can see that it is on the floor. It may be that you can use a lower value than minus 5, but I found that that works okay for me. You don't want to go too high because otherwise your character will completely stick to the floor. And next we're going to check that when it's on the floor, if the space key has been pressed, so if input is key pressed, and then in brackets here we're going to write in capital letters key underscore space, and again put a colon at the end. So we're saying if this has happened, then do this, and this we're going to do is make the velocity much higher in the y-axis. So I'll put 15. Again, we can come and we can change these values. Oh, I've missed out an equals there, so I need to tell it what it is. There we go. So velocity.y equals 15. What we're saying here is if the space key has been pressed, velocity is much higher, and this should enable us to jump. I'll save the file, and you can see that I've got this error here, error 3917, and what it's saying is there's a mistake on line 39. And having a look at it, I can see that what I've got there is I've failed to put a colon and instead put a semicolon. There we go. And hopefully now that error has disappeared. I can run my game by pressing the play button or whichever shortcut. And now when I press left and right, not only will it fall down the hole, but it should also jump over the gaps as well when I press the space bar. So that's working. Again, if yours for some reason is not working, check through that code, have a look at this code here and make sure that yours looks like it and everything is spelt correctly and indented correctly. The next thing we're going to do to our player is have it face in a particular direction and play any preset animations that we might have made in Blender or in Godot to make it look like it's running or jumping rather than just a sort of static pose as it moves around. So the next thing we need to do is make our player turn and face the direction that they're going in. To do this, we're going to make it rotate on the spot, and this is going to happen at the same time when we change the direction. So when we press the left key, it will face left and move left, and when we press the right key, it will go right and face right. For this to happen, we need to add a line of code to each of these if statements. Making sure I've got the correct indentation here, I'm going to write self. This is the object itself. Set rotation, and the rotation is going to be done in 3 dimensions. So we need to write vector 3 0. We're not rotating it in the x-axis. We do want to rotate it in the y-axis. However, because Godot uses radians to rotate objects instead of degrees, like most of us, we need to use a little operator called deg to rad, and that converts the degrees that we write to radians. so that Godot can understand it. Then we write in brackets how many degrees we want it to rotate. In this case 180, so it's going to rotate 180 degrees and face the other way, if you like, in this case left. And then finally we do another comma and we say no degrees in the z-axis. Notice the parentheses here, these brackets. We need to have a closing bracket for every opening bracket that we make, and sometimes this can be a source of errors. So here we open a bracket, we open another bracket, we open another bracket, then we close one of them, this one here, and they always work from the inside out. This one here closes this one here, and finally this last one closes this one here. So do make sure you've got those in the right place. We're going to write the same line of code, so I'm just going to copy this and paste it in the right key if statement. So in this case we actually want to change this 180 degrees to 0, so it's facing its normal direction, and that should make it face the right way. You might need to change these for your character depending on how you set it up in Blender. So have a look how it works and just type in the amount of degrees that you think it should be when it's facing either left or right. We can test this by pressing the play button up here, and now we should see that it's facing in one direction and now it's facing the other, and it just switches it round when we press those keys. To add the animations to our player, we need to use a couple of variables and we need to use some more code. To begin with, the variables are as follows. We're going to have a current animation, and at the moment it doesn't equal anything. There is no current animation, and so we're just going to put two sets of quotations like that. We're also going to make a variable called new animation, and that doesn't equal anything either at the moment. And finally, to be able to refer to our animations in the code, we need to specify which animation player we're using. So we're going to create a special variable that loads the animation player before anything else is done, and we write it like this: on ready var, and then I'm just going to call it my animation player. I can't call it animation player because that is reserved. Then I'm going to write get underscore node, and that should turn blue. And here it offers us some nodes that we can get, and you can see these are all nodes that are attached to our player, and the one we want of course is animation player. And you can type this in or select it from the list. If you type it in, remember to put the quotation marks. We can use this information now to help us play the correct animation at the correct time. First, in this func ready section, we need to give it a starting animation. And so at this stage we write current animation equals, and then the name of your animation. If you want to see what the animation is called, open up your player mesh, click the animation player, and you'll see that there's a little drop down list here with all the different animations that you've exported from Blender, and you can pick one of those and you can have a look at it going. We will come back to do some more with these after. I'm going to be using this standing one at the start of the game. Back to my main file and the player script. So current animation at the beginning of the game is going to be standing action. So we've told Godot what the current animation should be. Now we need to apply it. So my animation player, so this animation player attached to the player mesh, full stop, and then play current animation. Current animation being standing action. And now the advantage of this is that we can make current animation whatever we like throughout the script. So it may not appear too different at the moment. And if I test it by pressing the play button, we should see at the very start a little bit of movement and then it stops. We can make this loop in the animation player. So I'm back in the player object here, and I'll just click on it so we can see. There's the player. Here's the standing action. You can see that that just wobbles from side to side. And of course I want this to loop, so I'm going to press that loop button there, save the file, and have a look how that affects the main game. And there's the player just wobbling from side to side, waiting for us to do something. Back to the script on the player mesh here. We're going to now make it run when it goes in these different directions. And because this is being checked every frame, this is where our new animation variable comes in, allowing us to swap them around. If we write in here, underneath our previous controls, new animation equals run action, I can actually use that same line because it's going to be doing the run action in whichever direction it faces, and put it into the if statement here for the right key as well. Now at the moment, we haven't told it to play the new animation. We've told it what the new animation is, but we haven't told it to do anything with that information. We need to add some code that is going to swap our animations, and I'll do it down here, I think just below everything else. Because it's something that will be checking every frame, it needs to sit within this function, so I need to indent it once. I'll add another line in there just for a bit of clarity. So you can see it will sit at the same level as these other if statements, and this one is going to say if new animation exclamation mark equals, and this stands for does not equal. So if the new animation is not the current animation, and then we put a colon, in our first line in this if statement, which has been indented, we say current animation equals new animation, making sure that I get it spelt correctly and exactly the same way that I've created it in the variable. My animation player, full stop, play, and then in here I can write current animation. Just to explain this, what happens is each frame it checks to see if the variable new animation does not equal the current animation, in which case we're saying, if it's not doing what it was doing one frame ago, change it. If that happens, if the new animation is not the current animation, then make the current animation this new animation, then play that animation. And this allows us to swap through our actions as we play through the game. So we can test that and see how it's got on. And you can see that again, it's playing through that animation once, but then stopping. So we need to revisit our player, go to the animation player, and make sure that our other animation, so our run animation, is going to loop. We'll save that file and give it another test. And you can see this time it moves along much more nicely in whichever direction we're facing. It's floating a little bit, so I might need to just adjust my collision. Now we can see the next issue to deal with. I've let go of all the buttons and the player is still there walking on the spot. So we need to stop that. Back to our script. We need to add in some code here to check for when buttons have been released as well as pressed. And I'm going to do this. I'm going to make a little space here so you can see what I'm doing. This is another if statement, and because it's not dependent on any of these other things, we're just checking to see whether a key has been released. It sits at the same level here, so one indent in, and we're going to write if input full stop is action underscore just, and there it is in the list, just released. And we're looking at the same actions here, so we just type in UI left in exactly the same way, so making sure that I'm getting the correct characters in there. UI left, colon, and then one indent in, we want to say that the new animation equals standing action. And we're going to duplicate this and change that to just say right. So we'll highlight those two lines, copy and paste, making sure that I just delete that first indent. So in this case, we'll change left to right, and I'll test that now. And I've got an error here because I've not put colons, I put semicolons. So now the player walks along and then they stop, and you can see that the rotation has still been applied. So when the player walks to the left and then stops, they face away from us. So I would like to adjust that. I will copy one of the rotation lines of code and I'm going to pop it into each of these key release if statements. I've copied the one where each of the vectors is set to 0 degrees, so that even if it's been facing left, it will still switch back round to the front. That's right and to the front and left and back to the front. And that's what I'm after. And the final bit of code for this part is going to be the jump animation. This is going to be set off when the player is not on the floor. So here we've got the function is on floor. So just underneath this is on floor section, I'm going to make a new if statement with the opposite query. If exclamation mark is underscore on floor, and then the brackets or parentheses if you prefer. And what we're saying here is if it's not on the floor, if the new animation equals jump action. So don't forget, these bits here are whatever your animations are named. And we'll give that a try. Splendid. So once you've created your character movement and sorted out any errors and made sure everything's working correctly, then we can move on to adding some more interactivity and making the game a bit more challenging.